board.
Mr. Stro, are
Yeah.
we doing evens and odds? Or
No,
just
sir.
evens?
We're just doing the evens.
All right.
You're already supposed to work on the odds. Did you get a chance to do that?
No, I didn't know we were supposed to.
All right. Well, it really isn't a big deal. The video of the odds is posted. Okay. So everybody, if you're not sure, you can go back and just check the video on the odds. All right. And then get this turned in as soon as possible. All right. Looks like Mr. Wash is joining us. All right. So here we go, guys. All right. I appreciate you. Speak up as soon as you are having an issue. Okay. And the first 4 or 5 are probably review. All right, just basic equations. And then after that, they start picking up in difficulty. All right, please show your work. All right, that's the main thing. All right, everybody take a look at number 2 now. All right, we're isolating the variable. So to undo addition, we subtract 4. And then when you look at this, you just see x equals -13. All right, that should be straightforward. Everybody should know that. All right, number 4, that's still isolating the variable. Now there's dividing by -4. So to undo the dividing by -4, we say you're going to multiply by -4. And so I'm sure this is very easy for most. X equals 32. Next. All right, now we have a fraction. All right, so we're going to work through fractions and decimals. So again, speak up if you forgot how to do the fraction. All right, don't forget this is a plus 1/2. So to undo a plus 1/2, we're going to subtract 1/2. Now these guys cancel. So x equals 1/5 minus 1/2. So in order to do that, we have to get a common denominator. Common denominator is 10. So I need to multiply the first fraction by 2/2. I need to multiply the second fraction by 5/5. So I have 2/10 minus 5/10. So x is equal to -3/10. Anybody have any questions with that? All right, a good review of your fractions. Okay, number 8. Again, we're dividing by 4, so this time we multiply by 4. But in this case, you're multiplying 4 times 2/3. So when you multiply by 4 by 2/3, remember this is kind of by 4/1. Then you kind of check diagonally to see if you can reduce. Those numbers have nothing in common, so now we just multiply straight across. So we say x is equal to 8/3. Anybody have any questions with that? Nobody? Okay, now number 10. Okay, guys, you're still trying to isolate the variable. Now it's a 2-step equation. So that means you have to get rid of the +3 and you have to get rid of the times 9. All right, because you're trying to, again, you're trying to get at the x. So working backwards, PEMDAS backwards, you have to get rid of the addition and subtraction. So we're going to subtract 3 from both sides. Now these guys cancel. So we have -18 equals 9x. Now we divide both sides by 9. Divide both sides by 9. These guys cancel. So -18 divided by 9 is -2, and of course we would just rewrite this as x equals -2. All right, anybody have any questions? Nobody? All right. Number 12. Same kind of thing, except this time we're just dealing with decimals. All right, keep in mind I'm still trying to get to the x. So I have to add 1.5 to both sides. Add 1.5 to both sides. So here I have 2x equals negative 5.2. Now I'm going to divide everything by 2. So x is equal to negative 2 goes into 5 twice with 1 left over. 2 goes into 12 6 times. Don't forget the decimal. Negative 2.6. Anybody have any questions? All right. Told you it's going to be easy. All right. Now everybody needs to put a star by number 14. This is something new for you guys. All right. You're supposed to look at this and say, when can a number equal itself plus 1? Is it possible for a number to equal itself and itself plus 1? This in math we say is a contradiction. All right. That is not possible. All right. So if something is not possible, we say there's no solution. That's the symbol for no solution. All right. Now, just to be clear on this, I'm going to show you something. All right. Let's say you didn't recognize that was a contradiction. Right. What we do is we would subtract x from both sides. And the reason why we're subtracting x from both sides is because, again, you know from the previous lesson that I'm always trying to group my variables together, and I'm always trying to group my numbers together. So I want the variables on the left side, and I want my numbers on the right side. Left and right of what? We want it on the left and right of the equal sign. So if I were to move this x over with this x, I'd be subtracting x. Now, you can see it's a contradiction because these all cancel out. So the statement would simply read 0 equals 1. And 0 does not equal 1. Therefore, it's a contradiction, which means there's no value of x that I can replace x with that will be equal. All right. So again, put yourself a little star. All right. Go back, listen to the video, make sure you hear me properly, because now I'm going to give you another example. All right. The next example is going to be something like 2x plus 3 equals 2x plus 3. I want everybody to write that example down, all right, like I did. 2x, when does 2x plus 3 equal 2x plus 3? Well, what I want you to look at is this and this. All right, they're exactly the same. If they're exactly the same, we refer to that as an identity. We say that's an identity. And what that means is that no matter what number you plug in for x, 2x plus 3 is always equal to 2x plus 3. So we say the solution is all real numbers, all right? And if you recall, right before a couple weeks ago, we listed the names of all of the different sets of numbers. And all real numbers, this was the symbol we used for all real numbers. Now, how do I remember it's all real numbers? Okay, so what I'm going to do is I'll move this out of the way. What I just said, we're trying to group things together, so I'm going to move the 2x to the left. Then I'm going to move the 3 to the right. Now what you notice is that everything canceled out. So you end up with 0 equals to 0. All right. So everything canceled out, so you end up with 0 equals 0. And now because 0 equals 0, that's called an identity, which is the way you can recognize that it's all real numbers. Okay? So again, we had a good explanation on 2 different types of problems. All right? One possibility, new for you guys, is that there can be no solution when you solve an equation. Another one could be all real numbers. All right, so you now have either one answer, no solution, or all real numbers. All right. Now, please, the importance of being able to solve equations cannot be underestimated. You need to make sure that you know how to solve all of these problems, all of these equations. All right, all the videos are posted. So if you're not sure, you can go back, listen to the video, all right, and make sure that you understand completely what I'm saying. All right. Now, number 16. All right, this is again still from last week. All right, we could, instead of distributing, we can divide. This is the one case where we could just go ahead and divide by 4 first. Now, the reason why we do that is because this 4 and this 4 can cancel out. So now I have 2x minus 5 equals -7. From there, I need to get rid of the -5. So to get rid of the -5, I add 5 to both sides. Add 5 to both sides. And so now I have 2x equals -2. Divide both sides by 2, x equals -1. All right. Now notice, everyone, I'm showing all of my work. That's what I want you to do. Show everything that you're doing so I know you know what's going on. No skipping steps. Okay, now this one, we need to put a star by on this one. All right, because this is involving fractions. A lot of kids had trouble with this one, all right, because they forgot how to do the fractions. So let's take a look. All right, we're going to distribute 4 times 1/2, or half of 4. That's 2x. Now the common mistake is that kids forget to multiply the 4 times the -6 also. So 4 times -6 is -24. All right. Now what we're doing is we're going to multiply 2/3 times 6. All right. Now, to me, I always try to tell kids the quickest way to do this is take the 6, divide it by 3, which is 2, and then 2 times 2, which is 4. So that's 4x. All right. Now, does it matter if I go 2 times 6 is 12? 12 divided by 3 is 4. Same answer. The reason why I say I do it that way is because now when you come over here and you do it times 36, I'd much rather divide 36 by 3, which is 12, and then 12 times 2, which is 24. All right, that's much easier than 2 times 36, and then divide that by 3. All right, so now we're at this stage of the game. And again, just to remind you, we always want to try to separate the variables and the numbers. All right, so I want the variables on the left, and I want the numbers on the right. So just to mark this for you, just to show you what I mean. 2x is a variable, and it's on the left side. -24 is a number, and it's on the left side. 4x is a variable, and it's on the right side. -24 is a number, and it's on the right side. All right, now, again, I'm trying to just emphasize it's on the left and right of the equal sign, okay? So what does that mean? This variable needs to come over to the left side. So right now it's a plus 4x. So to move it to the other side, anytime you want to move something, you have to change the signs. So that's going to be a -4x, and a negative 4x. Now, this 24, the negative 24, I now want to go on the right side because it's a number. So I'm going to add 24. Add 24 to both sides. Now what happens is we just now read each one of these. Negative 2x minus 4x is negative 2x. These guys cancel out. These guys cancel out. And now negative 2x equals 0. All right, is everybody with me on that? Anybody have any question? Okay, so now what we want to do from here is we just divide by negative 2. Divide by negative 2. So x equals 0. All right, anybody have any questions with that? All right, that's the important part of the lesson anyway. Okay. Next one, number 20, a little bit harder. So please don't be afraid to speak up. No one said anything, so I'm hoping we're good. All right, so here we go. 4 times 3x, 12x. 4 times negative 7 is negative 28, plus 10 equals 12x minus 18. Now, is anybody having any questions with the distributive property there? Anybody? All right, now what we're going to do is we're going to combine terms. All right, so what I'm trying to do now is I'm trying to highlight these are numbers that are on the same side of the equation. So I wish you would combine those first. All right, so you would have to say, okay, what is negative 28 plus 10? 12x minus 18 equals, 12x minus 18. Now, hopefully that rings a bell and you say, well, wait a minute. 12x minus 18 is always equal to 12x minus 18. That is an identity, okay? So I need everybody to write underneath that. That is an identity. Which means all real numbers. All right, 12x minus 18 always equals 12x minus 18. That's always true. Now, let me go back to here just to make sure you understand what I'm saying. All right. Everybody listen to me for a second. Here's an equation. When is the only time the left side of the equation, when does the left side equal the right side? What number is that true? Come on, someone tell me. When does the left side equal the right side? The only time that's true is when x equals 0. There's only one possibility that makes the left side equal to the right side, and that's when x equals 0. All right? So again, this equation down here, when does the left side equal the right side? When is that true? It is always true. No matter what the x value is, it's always true. All right, hopefully you understand what I'm saying. All right, let's go back to 22 now. Here we go. All right, now here I put this one in here because a lot of kids don't realize there's an imaginary 1 right there. So we're distributing a negative 1. Distributing a negative 1. So that becomes 6x minus 1x minus 3 equals 3x. Now I want everybody to look at this. And what is 6x minus 1x? What's 6x minus 1x, guys?
5x.
Yep, thank you. 5x minus 3 equals 3x. All right. Now, because you guys are smarter, all right, I'm going to write something now that I want you to listen to carefully. I already said variables go on the left and numbers go on the right. Sometimes it's easier to put the numbers on the left side and the variables on the right side. All right, that's what I want you to think about. All right, so in this case, it's easier if because I'm trying to just separate the variables and the numbers, it's easier for me to go ahead and just say, look, I'm going to subtract 5x, subtract 5x. Now the numbers and the variables are separated from each other. The 5x and the negative 5x cancel. I'm left with negative 3 equals negative 2x. I'm continuing to isolate the variable, so I divide both sides by negative 2, divide by negative 2. And so now we just leave it as the fraction. All right, 3 over 2 equals x. But again, traditionally, we just usually write the x first. So we say x is equal to 3 over 2. Okay? Now, number 24 is very similar to 22. Okay, so what I'm going to do is I'm going to give you a minute. I want you to see how far you can go. All right, so everybody take a look now at number 24 and get started. I'm going to put a minute on the clock, and I want you to try as much as you possibly can. All right, I'm going to stop the recording for a second. All right, give it a shot. I'm trying to figure out how much you have accomplished or how much you understand. All right, so what we're going to do is we're going to go 2 times 5x. We're going to distribute. So everybody should have on their paper 10x minus 18 minus 7 equals 6x minus 12. Does anybody have any questions with that? Anybody have any questions?
Yeah, I have a question real quick.
Sure, go ahead.
For one of them, like when you did times 2, like for the parentheses, why didn't you just do divided by 2 for the whole parentheses? Like,
Very good question. Very good question, Austin. So the reason why we don't divide by 2 is because this 2 is only being, in order to divide by 2, I would have to divide everything through by 2. And since 7 is not divisible by 2, we don't do that. All right. So essentially, Austin, it has to be, if you're going to divide, it would have to be something like 2 times 5x minus 9 equals 12, where you could just divide by 2. All right. But if there's other stuff in the way, you can't just do that. Okay. Because if you divide one thing by 2, you have to divide everything by 2.
okay.
All right. So that's a good lesson. All right. Now, what I need everybody to do is we're going to combine terms. So this now, the negative 18 and the negative 7 is negative 25. Now we're moving variables to the left. So subtracting 6x. And then we're adding 25. Adding 25. So these cancel. So I have now 4x equals 13. Now I divide both sides by 4. and I have x equals 13 over 4. All right. So listen, if you understand how to do that, if you got that right, then you're in really good shape. Okay? If not, if you didn't get that right, you need to go back, pause the video, look it over, see how things are going. All right? Find out where you made your mistake. Anybody have any questions with that? Alden, you good on that?
No.
All right. Well, you got to go back and watch it again.
Okay.
All right. Now, if there's something I can help you with right now, you can tell me.
Okay.
Nothing?
I got a question.
Good. Tell me.
Oh, well, it's not really on the thing, but do we go to 51 on the evens?
You're going to end up turning this whole thing in. Yes.
All right.
All right. So here we go. Now we have another problem because we have fractions, and everyone likes fractions. So this is a review. All right. So here we go. Let's see what we can do. Variables on the left, numbers on the right. Variables on the left, numbers on the right. So the easy part here is to do the +5 and the +5. Then we're doing the -3/4 x and -3/4 x. Now, of course, the -5, the +5, those guys cancel. And then it's easy to see 8 + 5 is 13. But now I'm going to come over here and we're going to do 2/5 -3/4 together. All right, we're not using calculators. All right, the numbers are too easy. All right, so the common denominator between 5 and 4, hopefully you recognize is 20. All right, now what? Now we're going to multiply by 4. So 2 times 4 is 8/20. Multiply the second fraction by 5. That gives me -15/20. So 8/20 minus 15/20 is -7/20. So this over here would be -7/20 x. All right. Anybody have any issues with that fraction? Anybody have any issues with that fraction? Buddy? All right, so since nobody has any questions with that, we're now going to go back to, now how do we undo a fraction? All right, how do we undo a fraction? All right, we say we multiply by the reciprocal. All right, we multiply by the reciprocal. All right, so the reciprocal is going to be -20 over 7, -20 over 7. Now again, you'll notice these guys cancel. So x is equal to, nothing reduces. So 13 times 20 is -260 over 7. Remember, that's 13 over 1. Okay? Anybody have any issues? All right, here we go. Now, basically what I want to do is, I'm going to wipe out 25, and we're going to do number 25 together, because I noticed it was a proportion, and I want to just review that with you. All right, so you have to remember, when you're solving a proportion, you cross multiply. So you're going to multiply the 5 and the 2x plus 1, and you're going to multiply the 3 minus 2x times the 3. All right, why they call it cross multiply is because you're going this direction crosswise, and you're going this direction. All right, so let's go ahead and set that up now. So it'd be 5 times 2x plus 1 equals 3 times 3 minus 2x. Now when we distribute, I get 10x plus 5 equals, distribute the 3, 9 minus 6x. variables to the left, numbers to the right. So now I'm going to add 6x, add 6x, subtract 5, subtract 5. Now again, this right here becomes 16x. This guy here crosses out. So 16x equals 4. Now we divide both sides by 16. Notice 4 over 16 is a fraction. It does not equal 4. It equals 1/4. Okay? So that's a review of solving proportions. All right? Now listen, the video for the odds is posted. All right? Now, the next set of problems, believe it or not, is just kind of a review. The same problems, I just changed the numbers. All right? So your homework now, or your classwork, is to finish all the way up, like someone said, all the way up to 52. All right? However, some of you guys did not do the odds like I recommended. So now you have to go back and do the odds as well. All right? I'm going to stay online. All right? If anybody wants to ask me a question right now about a specific number, we can go back and do that. But your job is now to go and finish up the evens, and I will look them over and see how you're doing. All right? I also want you, if you haven't finished the odds, finish the odds as well. You have until the next class period to get it done, but I don't want to wait that long, obviously. I want you to go ahead and get it done as much as you can now, and then turn it in whenever it's done. Does everybody understand the instructions? All right? Since it seems everyone understands the instructions, you're free to get off now and just finish your work. And if you want to stay and ask me a question, all right, that you're having trouble with something, I'll be happy to sit and go over a particular problem with you. All right? All right, guys. You have a great day. All right? Does anybody have any questions right now for me that they want me to look at?
I have a question, actually.
Good. Tell me, which one?
I'm kind of confused in general on the whole variables on the right, numbers on the left thing.
Basically what it boils down to, is this Hunter? Who's asking me this?
Yes.
Okay,
Yeah.
so Hunter, listen, it boils down to this. It just boils down to the fact that you're always trying to get the variables on one side and the numbers on the other. That's it.
And so
like,
we would do that by like adding to
right,
each side?
adding or subtracting or combining. There's so many different options. That's what I'm saying. You have to look at each one and just, like, for example, 28. All right, you should look at 28 and say the 12 is in the wrong spot.
Yeah, wait, so you would just add the 12 to the 2?
No, not add the 12. You would do
You
what?
would subtract it then?
Right, because you want it to cancel. So this would be cancels. That would be subtracting 12. So then you would have negative x.
14.
Right. Now don't forget this is like a -1. All right, so I always tell my kids you can just change the signs, or you can say, well, I'm just going to divide by -1.
Yes.
And so x is equal to 14.
All right.
All right. Now over here, 30 is just straightforward. You just multiply by the reciprocal, right? And 32, you just subtract 3/5, right?
Yeah.
Let's go to something a little bit harder. So if I were to say something like this, right, you're going to distribute first. Do you agree?
So you'd have 10, or no, you'd have 3x.
Wait a minute. What's 5 times x?
5?
Right,
5x.
5x. And then 5 times -2.
Yeah.
What's
Okay.
that?
So you'd have negative 10
Right.
or
And
negative 10x.
now look what I wrote down.
So the 10s cancel out.
Right. Do you understand that so far, right?
Yeah.
So these guys now cancel. So
Then you take negative.
right. So now the negative 3x is out of position, right?
Mm-hmm.
So I would add 3x,
Which just cancels it out.
right?
And then wouldn't you do the same with the 18?
So you'd have 8x equals negative 18. Now, negative 18 is in the right spot. Because
Mm-hmm.
remember, again, variable equals numbers.
Yeah.
You agree with me or not?
So would x be 10 then?
No,
Because,
no.
no, wait, no.
You're dividing, buddy. Dividing,
Oh.
right? And how do I know I'm dividing? Because that's multiplication.
Mm-hmm.
So x is equal to negative 18 over 8, which reduces to negative 9 over 4.
Okay.
All right, so I appreciate some of you guys are still here online. You didn't leave. So does anybody else have a question? Brian, how are you doing? All right, go ahead. Whoever said that.
On number 25, this is just a quick question. Is there
Yeah.
any other way to do it?
Let me get there to 25. Well, no, you cross multiply.
Okay.
All right. Thank
Thank
you,
you.
buddy. Somebody else now. Good job, guys. I appreciate you. Anybody's online? Lily? Anybody? Nobody has any more questions?
Oh, Mr. Shaw, I have one.
Who's this? Mr. Strickland?
John.
Yeah. So what do we got, John?
I was confused on like how you just got it.
Which one?
20.
Okay, let's look at 20 again. All right, here we go. So let me just go ahead and pull this out from the side. Now you distribute, right?
Mm-hmm.
You see how that's 12x minus 28 plus 10 equals 12x minus 18, right?
Yeah.
So now you have to tell me about these two right here, buddy. What does
Do
that?
you add those? 'Cause
Yeah.
they're like,
Right, they're
okay.
not. So what's negative 28 plus 18?
wait, 18
Right,
or
negative 8.
minus 18?
You're right. Now what I really want you to be able to do, John, is just to look at that and say that's an identity. They equal each other. So it's always.
Okay. All right, thank you.
You're welcome. Anybody else?
Wait, I'm
Davis, is that you? Who else is on? Does anybody have any other questions?
no, I think I'm good.
I have another one actually.
Okay, go.
So for example, on number 30 and number 28, I did the minus 12 and that's gone, and then I did the minus 12 from negative 2, and now I have negative 14. But I don't know what to do next. Does that just mean that x is negative 14?
No. So it's negative 1x equals negative 14. So you divide by negative 1.
Okay. So, and then x is 14.
Right.
And then for number 30.
It's a reciprocal problem. You multiply by the reciprocal, which is negative 9 over 4. Negative 9 over 4. So x equals, two negatives make a positive. 16 divided by 4 is 4. Then 4 times 9 is 36.
Okay, thank you.
You're very welcome, buddy. Anybody else? Nobody else? All right, guys, I'm going to end it now. All right. And you guys have a great day. And let me know if you have any questions. All right.
Mr. Stroud,
Yes.
I have a question on number where is it? Number 28. I am quite confuzzled.
Okay, so are you hopping on and off, or are you listening the whole time?
No, I'm listening the entire time.
Okay, because again, Davis, I'm trying to help you, okay? So it doesn't matter to me, but 3 people, you're the 3rd person now has asked me about this problem. You see what I mean? And I don't care helping you. I'm just trying to figure out, what's going on, right?
Yeah.
So again, I don't care. I'm trying to help. I'm trying to make sure I'm teaching you, right? So I always want you to ask me a question if you're not sure about something. All right. So that's why I was just a little confused, because like I said, Hunter asked me about this one, and John Strickland asked me about this one, and now you asked me about this one. All right. And again, you understand what I'm saying, right?
Yeah.
All right. Don't be afraid to interrupt and say, hey, I don't know. All right. So you're still isolating the variable. So you're subtracting 12, right?
Uh-huh.
So now you just have negative x equals negative 14. Agreed?
Yes.
Right? So now you're undoing, this is like multiplying by negative 1. So you divide by negative 1. And so negative 14 divided by negative 1 is positive 14. Okay?
Ah.
All right?
Okay.
Max, tell me
Mr.
what's up.
Stroud,
Yes, sir.
could I have help on number 19?
19. Are you having trouble with the fractions?
Yeah, I just. Okay.
Do you see it now?
Yeah.
Are you sure, Max? Because I want to help you. So I'm, a lot of times.
Like how did you get negative 1/2 on both sides?
Well, because remember, Max, it's positive 1/2 on the right side.
Right.
So if I move it to the other side, it's minus 1/2.
Yeah.
Do you agree with that?
Yeah.
Just like this minus 2, I added 2 to both sides.
Oh, okay.
All
Oh,
right.
yeah. All right.
All right, buddy.
Thank you.
You're very welcome. All right, guys. You guys have a good day, okay?
Okay. You too.
All right. Take care, Davis.
Take care.